white light, so meaning visible light, remember visible light is between 400 and 700 nanometers. So our white light is incident on a 600 line per millimeter diffraction grating. What is the width of the first order rainbow on a screen 2 meters behind the grating? So remember yesterday we did the overhead projector. I used a diffraction grating to shine the light through there. And we saw this big old rainbow on the board. The violet end was down here. The red end was over here with everything in between. So violet light is your 400 nanometer end. Red is your 700 nanometer end. What it wants to know is how big is this? If you had like a meter stick and pulled it out, how long would it be? That's what the question's asking. So we know the diffraction grating is 600 lines per millimeter. That means the distance between the slits, right, 1 over 600 millimeters. So that's how far apart the slits are. We know L is 2, so the first order rainbow is on the screen 2 meters behind the grating. So L is 2 meters. It's the first order rainbow, so M is 1, exactly right. Alright, so this will allow us to find Y for the violet end, Y for the red end, and then to answer the question, what's the width of the first order rainbow, we'll just need to take the difference between those two. So our equations for diffraction grating, we have 2 equations that work. We have d sine theta is equal to m lambda, and we know that tangent of theta is 1 over L. Now please remember with diffraction gratings the angles are not small, so we have to leave the sine and the tangent in the equations in order to solve for this. So this top equation we'll be able to solve for theta. Theta is going to be the inverse sine of m lambda over d. In this second equation, y is going to be L times the tangent of theta. So it'll take us a couple steps. We need to find theta for the violet end, and then y for the violet end, and then likewise for the red end. So we have for violet, theta will be, m is 1, wavelength. Wavelength is 400 nanometers. So 400 nanometers, so 10 to the negative 9, over d, d is going to be 1 over 600 millimeters, so 10 to the negative 3. So theta for our violet line just takes me a little while to get there.
Isn't there a way to change tangent, arc, sine into some algebraic expression?
There could very well be
I remember doing that kind of thing.
trig identities, yeah. So 13.89 degrees. Now for y y for violet will be L, which is 2 meters, times the tangent of this angle. So y for violet, where is this measured from?
From the center.
From the center of that centered bright spot. So if you go straight across from the diffraction grating to the center of the bright spot there, this is measured from that location. Similarly for red, the same equations, the only difference is going to be the wavelength. The wavelength will be 700 nanometers. Thank you. So y for the red, tangent of that, times 2. So the red is located 0.926 meters from the center of the bright spot. Violet's located 0.494 from the center of the bright spot. So the width is 0.432, units, meters. So 43.2 centimeters wide is how big that particular rainbow will be. Questions about getting any of that?
How'd you get the 0.432?
Subtracted these two.
Oh,
So delta y is going to be how wide it is. So just subtracting y for the red minus y for the violet. That'll tell you how much distance there is between the two ends.